Everyone's comfortable? Can we go?
Pretty
All
comfortable.
right. Yeah. After all the spicy takes of John, I don't really know how to follow up with something even more spicy. My name is Toghrul. We have Jahnik. Oh, sorry. Jahnik, Guillermo, Alex, and Guillermo's alt here, or as people call him sometimes, Tarun. Guys, can you introduce yourself, please?
Sure. I'm Jahnik. I work on Shutter Network, which is a front-running protection / MEV minimization system that we hope to integrate into Rollups.
Hi, I'm Guillermo. I am a glorified paper editor at Bain Capital Crypto. I guess that usually translates to head of research, but I don't know what that means. So,
Hi, I'm Alex. I'm part of Flashbots. I'm a researcher steward working on all kind of MEV-related things there.
I'm Tarun. I founded a company called Gauntlet, but I also have written a bunch of papers trying to make sure that people realize MEV isn't always bad.
Good. All right, first question. MEV has become an established phenomenon amongst the community. Like, it went 4 years ago, it was just one paper, which like 10 people in the world knew about, and now it's like protocols are being built around it. So with L2s coming to the scene, what do you see the future of MEV like? Who wants to go first?
go for it.
I'm happy to go, but Jahnik, you also work on L2s if you want to start.
I can start maybe with a very short answer. I think it won't go away. It will stay there, but it will probably be different because there's in L2s, they work very different from produce blocks in different ways. So I hope to see different, new phenomena.
I actually disagree.
Shock.
Well, no, I mean, what do you mean looking different? Because
For example, sequencers centralized, and that works very differently. I also think there's space for experimentation. Like they can L1s have to be very conservative in how they design their protocol because there's lots of value, or at least on Ethereum. And Rollup does not have that problem, so they can just try out lots of different things. For example, different types of mempools, encrypted mempools, public mempools. Maybe I think you proposed this escalating fee escalation, something like that could be implemented in Rollup, like all this kind of stuff.
Wait, sorry. Could you? I have not heard of this particular proposal.
And maybe Flashbots better.
propose it ourselves, right? Like fee escalator is a concept as old as like maybe P1559. One of the design was like an escalator fee concept. I think Dan Finley from MetaMask is like one person that brought this up.
Here's an even dumber question. Escalator fee.
You submit a transaction with a negative fee, say, and so settle that transaction for you. And if no one settles it under a period, the transaction fee like escalates to a higher level. There's also any.sender from Patrick, who's right here, that did something similar, but that was more for like resubmitting the transaction to the mempool. There's a lot of these concepts. None of this is new, and it's about like better UX for users. In that case of what was proposed, and it's not something that we're building actively, was to having some type of order flow auction. So yeah, that's it.
And how auction on chain that does not suck?
Yeah, well, that's the problem with escalator fee. It's extremely central. The decentralized timestamp that you have is like Ethereum block time, which is super slow, and usually you want this auction to go quite fast because you want to be able to update the escalator quite quickly. But it's more interesting because they have like shorter block times, and so you're able to have more fun there. You can also just do more centralized infra and then see what happens. Again, I don't think it's a design we're gonna build. There are reasons why it's not as interesting to us, related to the leakage of like information that auction and other things related to this. And I'm sure you guys worked on DeFi and privacy in the context
never.
of AMMs in particular. So you're familiar with all
I
there.
have no idea what you're talking about.
So I think the one thing to remember, and maybe this is just a sign of being a boomer, is that if I look at the Linux 2.4 to 2.6, that was like one of the biggest sort of open source software upgrades in his anything crypto is 1/1 millionth at best of like how big of an upgrade that was, because every data center in the world to upgrade to this, because if you wanted to support multi-core or you want to support many different processors, different types of heterogeneity in your kernel, all of this shit, you couldn't do it unless you 6. And it was an upgrade that, you know, took like 10 years. And most of it was really fucking hard to schedule processes on multiple cores and to get that right, and to scheduling all the cache misses, to scheduling all the cache coherency protocols. There was a lot of went into that from, you know, probably hundreds of thousands of engineers. So rollups have the same problem. The difference is that instead of having a scheduler, you have this like set of many auctions that are interacting with each other that act as a scheduler. And that's an even harder problem. So I think like we should at least give some credence to the fact that Linux took so long to solve a much easier problem that had to be deployed to 99% of computers. And so I think in general, all of the people complain about information leakage. I've seen the same thing before, where when we moved to the first version of Linux, I think the efficiency ratio was like 10%, which was horrible. 90% of cores were sitting there spinning, doing in-spin.
Thanks for the Linux history lesson.
I have an answer to your question though.
Oh, sorry.
First,
Well, you know, I was just gonna say, like in general, right? Like centralized is just very, because you can have all these like nice economic efficiency problems, and in particular, right? Like a nice thing where you have, or don't have this nice thing where you have a bunch of interacting auctions, and like congratulations. The problem with interacting auctions, as like, if you remember like Milgram from like whatever the 90s auction Spectra, right? Like was meant to solve this thing of like you have a bunch of interacting auctions and like want to like, you know, succeed at one and then fail at the other, right? But like you can't guarantee that unless you like somehow have like additional higher level interaction. This is like kind of repeating Tarun's just more generally with like auctions. So this is why like I asked the question of like even mechanically, right? Like auctions like suck, right? And they'll suck even more because like now you have all of themselves don't come into consensus, like trying to like interact in like weird ways, right? So like do you have auction and like how do you do that? And then like, but then you have like auctions and auctions. So it's like you know, you can get really like with it, right? And be like, oh, like we continue to like deal with like meta auctions.
Was that DMT or weed? What was the implied smoke?
Both.
Yeah, exactly. Take your pick. Sorry, Alex.
I have an answer as well. I think like both of you are talking about like cross rollup stuff happening, right?
That's right.
Whereas, like, if I'm pronouncing your name right,
Yeah.
Jahnik. Jahnik was talking about like intra rollup, what happens, and actually I take back what I said before about like disagreeing with you. I agree with depending on the design that people go with for like their ordering policy, that's gonna like we're gonna see different behaviors from people going after like opportunities in these places. I don't think these behaviors are gonna be novel. So there are other chains outside of the Ethereum ecosystem that already have different ordering, and we see, or that you know don't have a fee market, and we see what happens, right? Solana getting spammed, Polygon getting spammed for different reasons. Just co-locating with Avalanche Foundation validators in order to be faster, and you see very similar behaviors today with their centralized sequencers. So I think depending on the architectural choice there, you're going to see different behaviors related to MEV. The second thing I would say related to MEV is I think rollups are going to be much more active with how they decide to harness that value. So if you take Optimism, for example, I think they're taking a pretty open and public position about like, oh, let's redirect some public goods funding, right? Other projects I want to do it differently. If you look at Cosmos, for example, you know, accrue value to the Atom token using an interchain scheduler, which is kind of like referring to. So I think there's like a big design space there, not only for redistribution, but also for like the ordering policy, the policy that you choose, and how that affects the activity that the searchers have. However, I don't think there's going to be like fundamental. Like, if I'm trying to think, is there MEV that like specific to L2s comes to mind is like stuff related to exiting the L2 or like censoring a commitment, stuff related to escape hatches or stuff related to you know, the L1 path that you can take to submit your transaction to an L2. These things are like quite specific to layer 2. And so maybe there's like new stuff there that we haven't seen before.
There's one thing I think that has not been analyzed, and which is the thing that everyone who is running a centralized sequencer is trying to avoid, even though, which is that if I have if I have two systems which are supposed to be synchronized, but they have two different fork choice rules, and I can't guarantee some bounded latency difference between the two fork choice rules, what's the probability that they can reconcile in under some fixed number of blocks? And the multiple fork choice rule reconciliation actually will probably create a huge amount of MEV when you go to decentralized sequencers versus single sequencer.
By multiple fork choice rules, you mean like two L2s again?
L1 forks and the L2 forks, and the L2 forks for a certain time length, and the L1 forks for a different time length. All of the existing guarantees that exist both formally and numerically for fork choice behavior, like ghost or anything like that, just go out the window. So this idea of like interacting fork choice was basically making MEV more, almost like giving some leverage to MEV between two chains, is one of the things I'd be most scared about with a decentralized sequencer on L2.
Next question.
Hey, you asked for something different than
I'm not complaining. Since rollups allow you to design the protocol from the clean, should we build the protocol from the ground up to mitigate MEV, incorporate it into the incentives of the protocol, and embrace it?
The latter. There's this like epistemic fallacy amongst certain people that you actually can come up to consistent ordering across many people with like differing utility functions and non-trivial differences. Like that's sort of a pie in the sky. I don't understand that information theory exists type of team.
I actually, which is if you build a DEX combined with L1 or L2, you can do things like market after every transaction. So there cannot be any like back running, right? Because by definition, like there exists no arbitrage if you've already routed, right? So like Penumbra is one such case. We have a number of other such projects. I think some of them are sitting somewhere around here. But the point is, like, you can, well, there's a whole question of like mitigate MEV or something, which is a whole weird other topic that I don't touch. But like vaguely looking at the outline of things around like MEV, you can kind of, you know, there's a lot you can because of the knowledge that MEV that happens on automated market makers has like this very specific, right? And you can exploit that pretty carefully to construct like things like mitigate MEV in the sense of like, you know, you have prices for all of your automated market makers at every point in time because you correctly route every orders, and you do not you like do not accept orders that only touch like a specific, you know, CFMM.
Again, like but you are making it's application specific.
Oh no, of course it's application specific.
Right. That possibility thing. Like, oh, I'm gonna do FIFO ordering for every fucking roll up.
Oh no.
That's just like ignoring even, like 50 years of.
No. I'm not even talking about FIFO ordering. Just generally like the non-existence of like you don't have to like you could do like whatever kind of, you know, ordering you like for this.
So what does that say about general purpose rollups then?
Yes. I mean, do you think as like a mechanism?
Ooh, I think you can generalize it in certain senses. So construct.
That's a bullshit answer.
Oh no. I actually have a very specific. Well, it's fair, but there are like specific classes of like protocols for which you can actually use the same trick in a lot of cases, right? Like, what does it mean for things to be consistent, right? We know what that means in terms of markets. It means in terms of like auctions, right? Like, there are answers you could make in this case. Like, I'm not saying you can do this for application. I'm sure there's some like funny little impossibility result where you construct an application, and that's fine. But like 99% of the stuff that we do right now, these two applications. So like, why not just get good and make them, right? That's my answer.
But then this begs the question of all those mitigation mechanisms involve consensus somehow interacting with the application.
No, absolutely.
Rollups do not do that.
Oh no, that's fine. Like that's I would say that's a them problem.
I think that's a philosophical.
Right?
That gets back to the debate of the last panel, which is philosophically, how much do you want your application intertwined with consensus or not? And that's like a religious choice.
Yeah.
It's like the choice of being an atheist or Christian.
Interesting. I didn't think theology on this stage. Jahnik, you guys are building something different, so what's your on this?
Yeah, I guess I have to defend it. Yeah, we're building this encrypted mempool thing, which prevents front running, I would say. And I don't think it has. Of course, it has some disadvantages. So it's not but it's definitely one approach we should. I think there's probably lots of other approaches we should try, and rollups give us to do that. So I don't really see why we should give up in mitigating MEV. I don't think we should. We should embrace it. I think we should do both. We should both mitigate and embrace.
Interesting. So you're saying that we can do both at the same time? Okay. All right. Anybody has anything to add?
Maybe comments on Jahnik. I totally agree with him, right? I think there's like, well, I think we're lacking like rigorous taxonomy for MEV, and so.
Should we just spend the next hour arguing about what MEV means?
Let's not. But people think when people say MEV, a lot of the time they think of which is they think of like stuff that's harmful to users, and I think it's like evident that anything that's better for the user experience should be considered and should be implemented. Ultimately, you want the system to get to as close to mass adoption as possible and to be as user-friendly as possible. That there's a lot of other types of extractable value that can be harnessed in the protocol. Of course, regulatory friendly, which also means
no. Let's
friendly.
not go there. Let's not go there.
Well, no. It means to users, right? The regulators are
users. Unfriendly to other users.
Okay. What do you say from? People get nervous. Of course.
So I guess I would maybe put out one possible like. There is the whole like if the only thing you have is everything looks like a nail problem that often happens in crypto. I somehow think the fact that we cannot even decide on a even minuscule definition of like which types of actions qualify means that any mitigation mechanism you have will actually verify whether it mitigated the correct thing or not or caused another externality. Like the fact that we can't even define what an externality to an MEV is formally is a distinct failure of this industry.
I mean, we can't even define what a rollup is.
Right, exactly. But that's a distinct failure. That means that we have a way to go before we can even talk about mitigation.
Next question. Value extraction is a centralizing force. How should we combat the resulting negative? Talking about externalities.
Wait, sorry, what was the question?
So, some say that MEV can be a centralizing force. And how do we combat the resultant externalities, negative, like censorship and stuff like that?
Well, I think you have a result on some part of this, at least. Actually,
Still
recently released.
Still working on it. Yeah.
Some alpha, maybe?
No, that's fine. It'll come out when it comes out.
All right. Anybody else?
So sorry, Jahnik, go.
Not really answering the question, but I would also say just because MEV is a central doesn't mean we should give in to that force. Like we could other forces to kind of counteract that. Like for example, simply social rules that we don't accept certain types of behavior if that's possible at all. Yeah.
Alex, anything to add?
I agree with Jahnik, and generally, I think you kind of made two distinct points. I think like there's like a rich get richer dynamic of MEV, and you want to that as much as possible. And so this is more about like redistribution mechanisms. I think it's like relatively underexplored as it's like most welfare maximizing. And again, I guess Optimism's position is invest in public goods. Yeah. People working on order flow auctions are saying, well, you give a rebate to the user, welfare maximizing, I guess. The work that these guys did is looking, for example, at like an instance of like saying, well, it can be welfare maximizing for the overall system and maybe not for the particular user.
I think the main idea there is like, if you redistribute the MEV captured in some manner that part is constructing the cryptographic mechanism such that the redistribution has very low cost of corruption. But if you could do, then you could basically actually rebate users so much that you can lower the inflation rate of the overall protocol, which MEV as a subsidy to users is a more than block rewards, right? And that's sort of a kind of powerful. You have to bootstrap your network with like block rewards until the point at which actually redistributing MEV means that you can not have to inflate as high. And I think obviously Cosmos sort of is going to go in that direction, sort of. I mean, there are too many conflating factors in the Atom 2 thing. But
I think I have a new name for your paper, which is incentive compatible communism ? So it's, I mean, I think the hard part about a lot of these mechanisms, right, is like this notion of incentive compatibility. Like, it's very easy to just like go off, like have an agreement off chain to be like, all right, cool, yeah, sure, we could like redistribute some of the. I could just submit exactly one bid that has like 0 like actual value, but we all like perform the auction and redistribute the profits ourselves. Right?
Yeah. I was
Prefacing it. No.
Prefacing it with that. I would say that like if we ever get to a world when threshold FHE works on chain, now obviously that's a pipe dream for anyone who's ever tried to implement these types of things. There are ways to actually achieve this. So I would say that like we could actually get to a good redistribution mechanism, but it sort of effectively needs homomorphic encryption.
Could you expand on the ways in which you could achieve?
So basically, you know, if we take kind of like the eigenlayer model one step further, right, where like users restake their stake and there's some slashing rules that are socially agreed upon for certain applications. One level further for that would actually be proving, just like as a ZK proof, but proving that on encrypted inputs that you get a correct output for an auction or for subsets of auctions. Do that, then you can basically show that the person had to have redistributed because they ran the code that does the redistribution to all the people who restaked to that particular.
But doesn't this go? Now you have an app that is like tightly controlled, like with consensus. Is like.
Okay. And this is why it gets back to religious differences.
Yeah. Okay. Good.
So basically, what you're saying is that we should tightly couple rather than making it. I'll use the popular word right.
I mean, the PBS model is sort of in that direction, right? Like Ethereum is clearly moving in the direction of coupling to consensus. Now the question is, what is the correct way of coupling it to consensus such that it's not affecting extra bad latency for the user, not that much of an improvement over the off-chain auction, right? Like some both improve in user usability and in sort of censorship resistance at the same time. And if you're not doing that, everyone will just go back to the off-chain auction. It's like doesn't make sense, you know.
Fair enough. What about PBS? What are your opinions on PBS? Should we go that way or a different route?
I have no consensual opinions about PBS, so
I'm happy to talk about it.
Yeah.
It depends what you mean by PBS, right? If you mean generally the like between who constructs a block and who proposes it, or
a more concrete version on the Ethereum has been people in Ethereum.
Okay, so even within Ethereum, protocol PBS and like in effect the out of protocol PBS, I think it's not clear yet whether it should. And I think that's at least my personal view. I think there's a lot of more work that needs to be done to understand the market economics and dynamics. There's also, I'll point you to a post from Barnaby that talks about, he kind of explains the full block PBS auction as like a set of more like generalizing this to allowing validators to arbitrary preferences on block space. So like if you have a credible commitment, a credible mechanism for like commitments between builders and one commitment can be, I want you to give me a full block. Another commitment can be, I want you to give me a full block with like this and this thing, or like a partial block given some rules. And that I think is quite interesting. Again, it's relatively underexplored, but it makes a lot of sense. Yeah, there's the trade-off of adding more overhead on validators, and so that has to be considered. but I think you can have like negligible in like the kind of templates that they can look at, but giving them a lot more expressivity about like what they want, which is ultimately, I think, what. So I think my trouble with like the current PBS, it's currently like full block, and it has some benefits. There's a lot of features you can build on top of that as builder, but at the same time, it has like a lot of drawbacks. Yeah. So I think the jury's still out of protocol. It's not clear how it's implemented in protocol, the way that makes sense. There's like a 2-slot like right now that was proposed by Vitalik. It's not how it would evolve in the future if like Ethereum moves to something like single-slot finance. And so there's a lot of these questions that have to be considered like with the question of in protocol PBS, and also how it interacts with future upgrades of the Ethereum network beyond single-slot finality.
Any other opinions on this?
Maybe the general question about PBS, should we do that or not? I would say probably too late for that question. PBS is there and will be very hard to convince to give up a big fraction of their rewards with them. So what we have to do now basically is to improve the as much as possible, and that can be either outside or inside of the protocol.
The question is more, should we shrine it or should we keep it separate to the consensus?
I wouldn't shrine it right now, to be clear. Like I don't think, like, compared to the work that went behind the IP 1559 to include it in protocol, reasoning that went into it, like the paper from Tim Roughgarden, the many simulations, the work that the robot did, and then compare that to like the formal like reasoning around PB, no comparison. So I think it deserves a lot more scrutiny. And again, just from that article from Barnaby, there's a big design space for how that should be. Generally separating a lot of the like heavier computing tasks that had to do in the past to like more specialized parties makes sense. It's like a separation of concerns that makes sense. How exactly do you separate this to preserve the of Ethereum is still something that needs to be understood. How does like this new market that's created interact with the other markets in Ethereum, fees on Ethereum, also has to be understood better. So my opinion, personal opinion, is it should definitely be included in protocol right now and requires more.
I mean, knowing Ethereum, it's not going to be included anytime soon.
I think the last thing I'd say is people in crypto, for some reason, probably just don't seem to pay attention to literatures, but there's this very famous trilemma in the algorithmic game theory literature from 2000 called the credibility trilemma, which is, you know, in some ways, Flashbots is the existence of Flashbots is proof that ETH has not gone over the credibility trilemma. So this sort of, it's funny when like multiple fields love the same word, because I hate the word trilemma. It's like, wait, the etymology of lemma.
So you're saying scalability trilemma is not a real thing?
No. Trilemma, right? Like if you think about the etymology of lemma in Latin versus like I in front of it, doesn't like read correctly. But anyway, the credibility trilemma is the following thing. There exists no auction with unbounded computational bid auctioneers such that you have the following three properties. One is credibility, that the bidders have to trust whether the auctioneer is lying or not. Like they can actually believe, they don't even need some mechanism by which they can observe the bids and they never have to actually try to prove that the auctioneer is lying. The second,
you mean lying from the perspective of submitting
so like the simplest example of this is, suppose you have a second price auction. The highest bidder pays the bid of the second highest. That bid is really high. Well, the auctioneer can just lie by putting in a bid arbitrarily close to the highest bidder and then force auction. So that's a sense in which it's not credible. Like the auctioneer bids, they can be censoring bids, they can be adding bids. So it changes the outcome of the auction. Property is truthfulness. Like people report the value that they actually that the object has that they're bidding on. And the third thing is bounded communication. The trilemma says you only get three of those. So the unique, credible, bounded communication time auction, the unique, truthful, bounded communication auction, block auction's a unique, credible, not bounded communication auction. And somehow understanding the edge cases of all these things should be very well understood far before you ever install PBS into the protocol.
So if not PBS, there's another proposal that is being discussed. It's a shutterized blockchain, so using thresholding to basically mitigate MEV, if you allow me to. What are your opinions on that?
Jahnik?
Of course.
Again, that's one of the mitigation minimization. I think the two approaches, they don't really oppose each other. You could implement both. And I would guess that even if I think it's very this will be implemented in Ethereum, but if it would be, then there would probably a PBS above that as well.
Why is it unlikely that it would be implemented on Ethereum?
Because it makes it adds basically additional security assumptions. You have to trust a fraction of a randomly selected fraction of validators more than others, and it's also just a very a somewhat complicated. So.
Can I ask a quick question? Do you have to use it separately, or can it be shared with the consensus as DKG if consensus had a DKG?
No, the DKG would be done out of the consensus.
Okay.
Anything else to add, or that's it? Next question. Okay. Proliferation of L2s. Is there? Do you know like the behavior of the builders who are gonna extract MEV change somehow? The behavior and the paths to like the most optimal are gonna be the same going forward.
So builders don't extract MEV, right? MEV is mostly extracted by validators who take like most of the profits, if not all of it. I think, again, what I mentioned before, right? There's like users on the other side of that equation, and right now, some instances of MEV can be exploitative to users. And so like thinking about like kickback systems that are like welfare maximizing for users of the system is valuable. So I think we'll see more of that for sure.
I meant more from the perspective of how important is it going to be in the future in terms of over MEV profits.
You're asking 2030 what percentage of MEV profit is cross-chain, right?
Yeah, 1st of January 2030.
Yeah. Percentage, I guess.
But only between rollups.
Doesn't have to be between the rollups, just in. Yeah.
Including centralized exchanges?
No.
I don't know. I mean, it's a function of volume and like how adopted are these systems. It's a function of like how many like mitigation technologies are mitigate against the extractable value that is harmful to the user experience. It's a function of like how much extractable value is lost to the Moloch. So how much extractable value is lost to a lack of coordination? How many coordination mechanisms that are not centralized, coordinated by a centralized coordinator, can exist in ways that like unlocks value for the system. So part of that questions, part of that is understanding better how to unlock like coordination between parties in the systems. It's kind of I don't have a number for you. Yeah.
I wasn't expecting it. I was just expecting it to.
He wants a distribution supported 100% with no add-ons.
I don't know. Well, I guess yeah. I don't like. I could imagine things, for example, like things that could become very, very large, or like very large in terms of volume, is like routing or like arbitrage across chains. Like and right now, I think players are fairly unsophisticated for that kind of thing. I don't really know that many players who are like truly doing like real cross-chain shit. Like,
well, very, very, very sophisticated players doing cross-centralized.
Oh no,
right?
that's for sure, right.
But that's the lowest hanging fruit, right? Because it's the most against the largest liquidity pools. So if that happens, like rollups gain more liquidity and you have like more paths to take that are like meaningful for these traders, then I think they will do that as well.
Right.
But I think it's unsophisticated partly because like the people that know how to do this right now just have like other problems, like lower hanging fruits to look at.
I mean, one of the, like when you're doing, if you talk to searchers who do this, DexArb across the bridge, because with DexArb you kind of like know your net loss before you submit the transaction. But people who are doing liquidations actually have a ton of problems because if they can't repatriate the liquidation profit from the destination chain back to the source chain, they're holding a bag of something that could have gone down 20%. And so it's hard to hedge anything that you have to do round trip versus things that you only have to do by unidirectional on bridges. And so that completely changes, and essentially if you're hedging on the same exchange, right? It's like my net position on Binance or FTX is I'm short a perp, like long whatever the collateral I'm selling is, but on bridges we don't have that. And so bridges, if offering services like letting you hedge your liquidation, you may start seeing bridges look like exchanges.
I was going to say already today, some of the largest bridges are centralized exchanges, right?
Yeah, my favorite bridge.
On Binance and Coinbase, yeah.
Yeah, is like halfway, somewhere in the middle.
Yeah, but it's not really a trust bridge there. Not like it's quite centralized as well. Guys, unfortunately, time. I would have loved to continue discussing stuff, but yeah. Thanks everyone for listening. Big round of applause to these guys.